Greetings and hello everyone. Today we're going to be looking at solving one-step inequalities. Let's start off with a definition. So what is an inequality? And that is a mathematical sentence that contains the symbols or so an inequality compares the values of two numbers or expressions using these symbols. So these symbols are greater than, less than, greater than or equal to, less than or equal to, or not equal to. So let's take a look at example 1. It says graph the solution set of y is less than or equal to 4. So we want to find values less than or equal to 4. And when we have this, 4 is included in there. That's what the or equals to means. So that would be a closed circle or a dot. If it was just less than, then we would have an open circle. So let's build the number line for this. So I have 0, 1, 2, 3, 4, 5. And we want values that are less than or equal to 4. So we're going to go to 4, and we're going to do a closed circle. So it means we're going to make a dot right there on 4. And we're going to shade values that are less than that. So we're going to go to the left. So any value that's to the left of 4 will work for this problem. So let's take a look at example 2. So example 2, now we're given the graph and we want to create an inequality statement. So this is an open circle. So that means we're going to have just greater than, or we're going to have less than. And then we want to see. So these are values that are going to the left, so that are values that are less. So we're going to have x is going to be values less than, it's just going to be less than because it's an open circle, and they're going to be values less than 1.4 or 1 4/10. So that's how you would do problems that look like this. So let's take a look at the next one. Before we look at the next one, I want to define something. This is called set builder notation. So that would look like this. And we read this as set of all numbers x such that in this case x is greater than or equal to 4. But the big one is right here, x such that x is. So set of all numbers x such that x is. That's this part right here. This part is going to change depending on the problem that we're looking at. So let's do a little bit more defining. So if the same number is added to each side of a true inequality, the resulting inequality is true. Is true. So what will that look like? Well, if I have if, that's hard to read, if A is greater than B, then A plus C is going to be greater than B plus C. And then if A is less than B, then A plus C is going to be less than B plus C. So that's for addition. Let's define another one. If the same number is subtracted from each side of a true inequality, the resulting inequality is also true. So that's the words. What does the symbols look like? Well, if A is greater than B, then A minus C is going to be greater than B minus C. Also, if A is less than B, then A minus C is going to be less than B minus C. So this is going to help us out with the next couple of problems. Let's take a look at them. So we want to solve example 3, 4, and 5. Once we solve it, we're going to put it into set builder notation. So here I have x minus 10 is less than 15. So what I'm going to do is I'm going to add 10 to both sides. So just like with equations, we have pretty much similar properties with inequalities as well. We just have a couple of differences, and we'll see those when we come to those. So I'm not doing anything with the variable, so I'm just going to drop that down. So it's going to give me x. This gives me a 0 is less than 25. So if I put this in set builder notation, set of all numbers x such that x is less than 25. Let's take a look at the next one. So I have x plus 24, so I'm going to subtract 24 from both sides. So here I added, I used the addition. Here I'm using subtraction. I'm not doing anything to the x, so I'm just going to drop that down. This gives me a 0 right here. 61 minus 24 is 37. So x is going to be greater than or equal to. So if we put this into set notation, all values of x such that x is greater than or equal to 37. And then the last one, well, here we have 9y plus 3 is greater than or equal to 10y. So we have y's on both sides. As we saw with equations, we only want to have the variable on one side. So I'm going to get rid of the smaller variable. I'm going to subtract 9y from both sides. I'm not doing anything with that 3 term, so I'm just going to drop that down. So this is a 0 right here. So this gives me 3 is greater than or equal to 10 minus 9 is just y. So this is the set of all numbers y such that I can change this around and say y is less than or equal to 3. Means the same thing. Here 3 is greater than or equal to y, which means that y is less than or equal to 3. All right, let's take a look at number 6. So Hassan's wireless contract allows him to use at most, so that's a key word right there, at most. 5 gigabytes of data per month. At this point, Hassan's used 3.7 gigabytes of data. How many gigabytes of data has Hassan used, or can Hassan use for the rest of the month without exceeding his maximum allowance? So we can't go above 5. So 5 is our max. So we need values that are less than or equal to 5. So we're going to use G for gigabytes. And then how much have we used so far? Well, we used 3.7. So here's our equation. 3.7, the amount used, plus however much he can use still to get us to 5. So now I'm going to subtract 3.7 from both sides. So that's going to give me G is less than or equal to 1.3. So he can only use 1.3 more gigabytes of data. Once he does that, he hits his limit. All right, let's do a little bit more defining. So if each side of a true inequality is multiplied by a positive number, the resulting inequality is also true. So what does that look like? So if A is greater than B, then A times C is going to be greater than B times C. And then if A is less than B, then A times C is going to be less than B times C. Now here's the change between equations and inequalities. If each side of a true inequality is multiplied by a negative number, so we'll underline that, negative number, the direction of the inequality sign must reverse to make true. So what does this look like? If A is greater than B and we multiply by a negative C, then AC is going to be less than BC. And then if A is less than B, then if we, again, negative C, AC is going to be greater than BC. We have to change the direction of the inequality sign. That's why I'm circling these to kind of draw your attention to it, because this is different. This is one of the big changes with inequalities. All right, let's try an example. So we've read about 1/4 of a novel. We have at least 112 pages left. How many pages are in the novel? So we've read 1/4 of the novel. We have at least 112 pages left. So that means it could be bigger than that, but that's the minimum. So how many pages could there possibly be in the novel? So we're going to solve this inequality right here. So I'm going to multiply both sides by 4. When I multiply both sides by 4, that takes this fraction, it turns it into 1, because it gives you 4 times 1 divided by 4, which is just 1. And then we have 112 times 4, which is 448. So about 448 pages. So let's take a look at example 8. So solve negative 2/5 x is less than or equal to 11, and we want to graph the number line. So I'm going to multiply both sides by the reciprocal of this. And the reciprocal of this is going to be negative 5 over 2. Why is that the reciprocal? Because 5 times 2 is 10. 2 times 5 is 10. So we get 10 divided by 10, which is just 1. 11 times negative 5 is negative 55 over 2. But there's something we need to do, and we need to flip this. Why do we need to flip this? The reason we need to flip this is because we multiplied by a negative. So that's why we need to flip this. So in set notation, all values of x, such that x is going to be greater than or equal to negative 55 over 2, which is also 27.5. So if I make the number line for this, negative 25, negative 26, negative 27, negative 28, negative 29. So we want negative 27.5. It's going to be a closed circle, so we're going to put a closed circle right here. And we want values that are going to be bigger than that. So we're going to go to the right. Let's take a look at example 9. So solve this inequality right here. So I have 20x is less than 4. So I'm going to undo multiplication with division. And division is just like multiplication, same rules and everything like that. So if I divide by a negative number, I need to change the sign. I'm not dividing by a negative number here. So 20 divided by 20 is just going to be 1. 4 divided by 20 is going to be 1/5. So we want all values of x such that x is going to be less than 1/5. Let's build our number line. So we have -2, -1, 0, 1, 2. So we want 1/5, which is about right here. This is just less than, so it's going to be an open circle. And we're going to shade everything to the left. Now let's take a look at our last one. So we have -13z is greater than or equal to 117. So we want to undo this multiplication. We undo multiplication with division. So I'm going to divide by 13. I'm dividing by -13. So that means I'm going to flip this sign. So -13 divided by -13 is going to be positive z. I flip the sign so it goes from greater than to less than or equal to. And then 117 divided by 13, well, that's going to be -9. So we want all values of z such that z is less than or equal to -9. So I have -5, -6, -7, -8, -9, and -10. I'm going to put a closed circle because it has or equal to. So I'm going to put a closed circle at 9. And I want values that are less than that. So I'm going to shade everything to the left, less than -9. And that's how you solve one-step inequalities. Have a great day.